All right, let's do a few practice problems together. This is taken from an old IBSL exam. I rank it as an easy to medium kind of style question. Doesn't mean that we can't practice it though, and doesn't mean that it's not applicable for you HL students out there. It's all good practice. We have two functions. F of x is equal to 5x, and g of x is x plus 1, where they tell us specifically that x is the domain of x is such that x includes all real numbers. We have two questions. First, we need to find the inverse. Then we need to find the composite function and evaluate it at a certain number. They're both these questions or parts A and B are independent of each other, so we can handle one, then the other, no problem. So let's start with part A. To find the inverse of this function, where I'm just going to rewrite this, we are first going to take our original f of x function and write it as an equation. We are then going to take this and switch the x and the y variables out. So x is equal to 5y. And the last step, this is a pretty simple one. We're going to solve this for y by dividing both sides of this equation by 5. The 5's cancel out, so we're ending up with y is equal to x over 5. And this is our inverse function. 2 points in the bag. Checkmate. For part B, let's do it over here. We need to first find the composite of f of g of x, then evaluate it at 7. That's what that notation is saying. So we notice this is worth 3 points. It probably is going to take one extra step from the inverse one, but not too bad. So first, let's go ahead and solve for f of g of x. And we're going to do that by plugging in the g of x function, x squared plus 1, inside the f of x function. Okay, well, f of x is just 5x. So I'm going to take 5, and wherever I see an x, I'm going to plug in x squared plus 1. This is my composite function, f of g of x. Then, if we're going to evaluate it at 7, hold on, let's erase this. If I'm going to evaluate this at 7, I'm literally just going to plug in a 7 wherever I see an x term over there. Okay, well, the 5 stays the same. It's just a coefficient times 7 squared plus 1. 7 squared is 49. 49 plus 1 is 50. So this is just equal to 5 times 50. 5 times 50 gives me 250. And that is our final answer. All right. Here's a slightly more difficult example. It's from an old IB exam. It's still a standard level question, but I'd reckon a little bit more challenging than the previous example we worked on. It's got two parts, a part A and B, but still functions. Let's get to it. First, we've got the function. I'm going to rewrite it just so we have it written down ourselves. F of x is equal to 2x minus 6 over 1 minus x. For part A, let's start there, and it asks us, for the graph of f, which we don't know, we haven't seen yet, find the x-intercept. Okay, the x-intercept is just another way of saying the root, and the way we find the x-intercept is, well, that's going to be the case when the y value is equal to 0, right? So we can literally set the equation equal to 0, 2x minus 6 over 1 minus x. An equation is only ever going to equal 0, or a fraction is only going to ever equal 0 when the top of the fraction is equal to 0. The denominator is never allowed to be equal to 0. It gives us that weird undefined thing. So the only way this is going to be true is when 2x minus 6 is equal to 0. To figure this out, we can come over here. We can rewrite this as 2x is equal to 6 by adding 6 to both sides. X is equal to 3 is our final answer for the coordinates, the x-coordinate of the x-intercept. So just for the sake of completion, I would put that the x-intercept occurs at 3, 0. It's at x equals 3, and it's when y is equal to 0, because we know that that is exactly the point where it intercepts the x-axis. This is for part A1, sorry. For part A2, it asks us to write down the equation of the vertical asymptote. All right, let's figure this out. The vertical asymptote, if you were paying attention to my previous videos, is directly related to the domain of the function. The vertical asymptote is telling you the equation for the point that's off limits. Well, it tells us, since they tell you that the domain for this equation or for this function is all real values of x except for when x is equal to 1, because that's when the denominator goes to 0. Super simple. The equation for the vertical asymptote is literally just the equation x equals 1 when that x value is off limits. That's it. Last part here, A3. Find the equation of the horizontal asymptote. This one's a little bit trickier. To do this, I'm going to rewrite our function, or just the expression of our function, 2x minus 6 over 1 minus x. And I'm going to ask myself, okay, let's look at where all the x's are. If there are x's in the top and bottom, let's compare their powers. I see an x term here in the top and an x term here in the bottom, and they're both raised to the first power. If you remember, if both x terms are raised to the same power, then they're both going to be increasing and decreasing at the same rates. So to come up with an equation for the horizontal asymptote, I'm literally going to take the ratio of their coefficients. So the coefficient for the top x term is 2. The coefficient for the bottom x term is -1. There's a 1 hidden in there, which we just usually don't write because it's implicit. So 2 divided by -1 gives me a -2. So the equation for my horizontal asymptote is y is equal to -2. That's it. I'm going to skip part B for this one. The limit of f of x is equal to, or solving for the limit of f of x. And the only reason I'm going to skip it for now is because that's not in the functions unit. That's a calculus topic, topic 5, which we're going to cover in a future series. So let's leave it at that for now. 5 points in the bag.